Good morning. Welcome to the chat at ISC. My name is Horst Simon. I'm the Deputy Director of Lawrence Berkeley National Labs. And this is the second time we're trying to do this chat at ISC. Just want to explain to the audience who didn't join us last year what the idea behind the chat is. Think of it really as a friendly conversation among experts. And I'm not the expert, I'm just guiding the conversation. So what we'd like to accomplish here is that you can listen in your neighbor's table at the reception or at the dinner time after the conference is over, where some of the experts talk about what they've heard, what they've seen, what they're doing, and compare notes. So this is less stressful than a panel session. There are no prepared notes, there are no prepared slides. There's only time pressure in as far as that we will be done in an hour. And furthermore, I hope it's very interactive, friendly, and we will get to, of course, audience participation towards the end. So with this, I would like to switch over and sit down comfortably and then start the chat. So in this chat, I will have three guests, and I will call them in one after the other, and then have a short conversation with each one of the guests, and then we'll all join to a group conversation. And in trying to get a right group of people together in the chat, I have tried to get geographic diversity. So we have one participant from Europe, one from the United States, and one from Asia. I also try to have diversity with respect to their background. So we have one center director, one software developer, and one general organization that helps technology development and competitiveness participating in NGO. And so in that sense, we'll hope to have all perspectives on the missing middle represented. So I was asked what the missing middle is. It has become a very catchy word. It refers to the fact that supercomputing for many years, and I think even today, has remained to be a very, let's use the word, elite activity. That is, it's used by the big research centers, by the universities, and by some very large technology companies. And most of the technology companies, if they use high-performance computing, modeling, and simulation, do this at the level of a desktop or small-scale server. So there's a big gap, as we all know, between what you can do on the desktop or in a departmental server and what supercomputers can do. And this big gap has not been bridged yet, in particular in terms of industrial computations and modeling and simulation industry. Furthermore, there are more barriers to make high-performance computing useful in industry. For example, the availability of third-party application software. The question of, is there enough talent out there? Are there people who know what modeling and simulation is doing? Can the companies really appreciate the role of modeling and simulation? So all this complex set of questions which have to do with the industrial use of supercomputing by a broader perspective and broader set of users, that has become the missing middle, and that's what we'd like to talk about it. And it fits perfectly well into ISC, since ISC has an industrial track. Actually, the origins of ISC, when Hans started this in the late 80s in Mannheim, was actually a training and outreach activity introducing supercomputing to a broader spectrum of German participants, in particular industrial participants. So in some sense, we're almost back to one of the roots of ISC. So with that, I would like to introduce our first panelist or chat partner. He is Dr. Jisoo Lee, who is the president of the National Institute of Supercomputing and Networking in Korea. He received his undergraduate degree at the Seoul National University and his PhD in physics at Boston University, and then spent 2 years actually here in Germany at the Jülich Research Center. And so he's very well familiar with high-performance computing also on the European side. Then he moved on to San Diego before he took on his current leadership position in Korea. So he will join me, and I would like to introduce him with sort of one interesting thing. I visited his center 2 years ago or 3 years ago, and we talked about industrial usage of the supercomputers. And one project that stood out for me was that they talked about how to optimize the rice cookers using supercomputing simulation. I said we wouldn't find that consumer use of HPC that easily in the US. Certainly will be a big challenge to make it happen. So I thought he's probably somebody who can add to the conversation. Welcome, Jisoo.
Very nice to see you.
Thank you for coming. Good morning.
Nice to have you.
So I'd like to start this out and maybe give you, Jisoo, a short opportunity to talk a little bit more about your center and what the current developments are at your center and what the most important topics of conversation are in Korea.
Okay, so I guess I'd like to start with some description about the Korean Supercomputing Act. So basically, that we all agree and we all know that supercomputer is a useful tool that can be used in wide areas of the society. And unfortunately, in Korea, it's not doing a good job, I feel, in that respect. So, I mean, this National Supercomputing Act, which is something like the HPC Act of the United States, is a way to challenge the situation. So, I mean, what happened is that the act was passed about 2 years ago in the June of 2011, and then they need an organization to support the planning and execution of the whole plan, and that is my institute. It's the NISN. It's the National Institute of Supercomputing and Networking, and we start at the 1st of January of this year.
So one thing that is, of course, known to everybody is the rapid growth in terms of technology companies in South Korea who've started in the 70s and 80s with very small beginnings and now have become brand names worldwide. How much did HPC have to do with that growth, or can you claim any past successes there?
Yeah, I mean, there are some, but not enough. I guess that's the conclusion. So, I mean, the history of supercomputing in Korea is history of my center. So we started our service about 25 years ago, actually. And then when we first opened the facility, that all these big companies are our customers, so like a Samsung and Hyundai, they are our customers. So once they realized the value of supercomputing, and these people, they have enough fund, so they decided to build their own facility. So, I mean, Kia Motors actually is the first company that started to have their own facility, and followed by Samsung and Hyundai and LG and most of the big companies in Korea now have their own facility and have been upgrading the facilities. So in this respect, I mean, there is some impact on that one. But when I just compare the situation in Korea with other countries like the US or Germany or UK, I feel that we are not doing that great a job, so we have to do something more then.
Okay. Anything else that comes to mind about HPC in South Korea at this point? The top 500 list just appeared, and so you probably are, like many countries, looking at an international comparison on where you stand and where you could do better, and how does that look today to you?
Yeah, that is actually the call I received this morning. That we have no new system, so in that respect, I mean, our ranking is keep on declining, and so I mean, hopefully what happened was that after this law was passed, we have so-called like 5-year master plan that has a plan for the investment. So hopefully with this plan, this situation will just take reverse toll, but that's just remain to be seen. But I mean, our Chinese friend, I guess, is doing a lot of favor to many countries, I believe.
Okay. Also in Korea, I guess.
Also in Korea too.
Good. Okay, well, thank you, Jisoo. I would like to introduce our second participant in the chat. Her name is Karen Lukasiewicz. She is a software developer with Magma, and I can pronounce this, Gießereitechnologie in Aachen. So you will probably wonder what that means if you don't speak German, but she will explain it to us. So she has received a graduate degree from Aachen University, and she will join us to talk about software. Welcome, Karen. Have a seat, please. So, as I indicated, we don't really know that much about MachMine, what Gießerei technology is in supercomputing, so maybe you can tell us for a few seconds on what that is all about.
So our company called Magma was founded in 1988. So we have our 25th anniversary this year. And it was a spin-off of the Gießerei Institute at the Aachen University. And our software is called MagmaSoft, and it gives you insight in the casting process and helps the foundries and casting designers and casting users to predict what's going on in their process and help them to optimize their processes. So it always was, our software was the first one with a graphical user interface, and we pulled out the simulation out of this text file-based corner. And it always was designed for the foundrymen to use in foundries. But we have our customer base are mainly small and medium-sized companies, but we also have several big automotive customers.
So maybe you can say a little bit more about your customer base, how many licenses you have and what platforms you're running on, what the largest systems are that you're currently running.
The largest system, I think, are 128 cores. Most have 32 to 64 for the cluster license, but mainly we sell licenses 4, 8, 16, what you can put under your desk. So for the smaller ones, they normally don't buy these big cluster systems. They buy what they can put under the desk.
Okay. So maybe you can give us a little bit of general sense on, I mean, if you read newspapers in journals like The Economist in America, there's a lot of conversation about German Mittelstand enterprises and using all kinds of interesting technology. What is your experience in terms of smaller scale companies in Europe and Germany and how they react to HPC, and is that different from what you know about the US or in Asia?
Yeah, the funny thing is that we sold more cluster licenses in Europe than in the USA or in Asia. And even more middle or small-sized companies. The smallest company that bought a cluster license is about 500 employees. The other two ones are about 2,000 employees. And I think it's quite remarkable because they jump into new technologies. As I experience, it's not so much the question of the country, but of the people. So some dare to try out new things. Some say, okay, this is what I always wanted, I know what I can do with it, and the other one cling to what they knew.
So do you think that's also part of the education and training that staff in those companies has?
Yeah, it depends. So, of course, it's some kind of training, and it's some kind of how you are used to it. So, several years ago, 4 cores or 4 processors was big regarded for such a small company. 8 was even bigger, and now you have a mobile phone with 4 cores in it, so it's normal for the people now, and they ask, so if I have it on my mobile phone, why can't I have it for my simulation?
Okay. Good. Well, let me introduce now our third panelist. Her name is Dr. Cynthia McIntyre. She's Senior Vice President at the Council of Competitiveness, a nonpartisan, non-governmental organization in the United States, which is dedicated to developing public recommendations to enhance American competitiveness by creating new domestic jobs in the US. At the Council, she has a proven track record of cultivating government and private industry collaborations to create various new technology innovations. She was recognized by HPC Wire as one of the top people to watch in 2013. And during the last 5 years, I've got to know Cynthia because she has been a very tireless supporter of high-performance computing and has in particular worked with HPC centers and industry to develop programs and concepts to make HPC more useful to industry and more used by industry. For this, I'd like to welcome Cynthia. Welcome.
Thank you, Horst. It's a pleasure.
Great to see you.
Nice
Thanks for
to see
coming.
you. Thank you.
Cynthia, again, For the European audience, maybe we want to start out and you can give us a little bit more background about the Council on Competitiveness and your work, especially with respect to high-performance computing.
Certainly. Let me tell you a little bit about the history. The council started in 1986 in Washington, D.C. At that time, the U.S. was undergoing some economic stress, and trade issues were very big. So John Young, who was the CEO of Hewlett-Packard, started the Council on Competitiveness so that a not-for-profit entity in Washington could advise the federal government on issues that were important for the private sector's productivity. And so we have been focused on technology, innovation, manufacturing, energy, those things that are of importance to the private sector over the time period that I've talked about. In 2002, our president, Deborah Wynn Smith, was talking to the various heads of departments and agencies in Washington, and was having a conversation with Dr. Tony Tether, who was the director of DARPA, around what are some of the critical technologies in the U.S. that could be of importance to the private sector going forward. And he said, you know, if the U.S. would focus on deploying high-performance computing, modeling, and simulation to the industrial sector, and policies and strategies to do so, it would make a big difference. And from 2002 forward, we've had, as a policy perspective, high-performance computing as an initiative, and have put out publications that inform the government about the importance of the technology to the university environment for their productivity, scientific, as well as development work, as well as the industrial use of the tools, from the large companies, the Boeings, the Procter & Gamble's, to small companies, such as Jayco Plastic Products, that has about 35 people who are now using HPC resources.
So in your current work, what are the particular challenges and what are you currently working on with respect to HPC?
The challenges in the work that we do is getting the, I'll say the legislators, the Congress of the United States to appreciate that this technology is not just for the scientific community, for the academics, for the national labs, but it can be a productivity tool for small and medium-sized companies as well as the large companies. And so they don't quite see how is this going to impact the machine shop in my district. And so we have a pilot project at the council called the National Digital Engineering and Manufacturing Consortium. It's a public-private partnership that the administration wanted the council to create with federal dollars and with private sector dollars to help small and medium-sized manufacturers. So we now have about 20 companies, small companies, 10, 15, 100 employees, where they've used high-end, we don't use the term high-performance computing with them, we see high-end modeling and simulation for their productivity. And they have gotten, some of them have gotten very hooked on using the tool. What we've done is increase their innovation space. They've said, oh my goodness, you've helped me solve this problem in a short time. I can now do this problem that I couldn't do before. And now I can go after this market. And so we have case studies that show the impact of getting the technology and the tools to SMEs who have no capability to buy or source the hardware, software, or expertise. So we bring those to them in an accessible way through a public-private partnership. We bring the universities in, the OEMs in to collaborate with the SME on the solution. So that's been a great opportunity for us. Some of the challenges that we see that the federal government has, As all of you know, the U.S. has a fairly constrained budget, federal budget. And so we are advocating to the federal government that as they prioritize their investments, that high-performance computing be one of those priorities, and that resources be deployed on development of the next level, highest level of compute, Exascale, that there should be investment there so that the U.S. stays competitive with everyone else who's pursuing that Exascale platform. So that's part of our opportunity to advocate that to the federal government. We think that we've done a good job in talking to the government about the use of HPC for small and medium-sized manufacturers. And in fact, there was a request for information that was available until, I guess, last week when all the proposals had to be in. There's a request for a digital manufacturing and digital innovation institute to be created in the United States to help SMEs, to help small and medium-sized manufacturers, as well as the large ones, to be more productive through the use of modeling and simulation. So we're very excited about that, that the government moved in that direction. There were other voices, not just the council, advocating for that to happen, and some of those players are here in the room. NCMS being one, Intel certainly has had a role in advocating that, IBM, many of the vendors, Cray, and the universities, University of Illinois, Champaign-Urbana, Ohio State University, and others have said, if you would help us to help industry to use these tools, you'll see greater productivity and greater economic impact.
So Cynthia just mentioned Exascale. That might be a good segue to bring Jisoo and Karen back in. And I wanted to ask the two of you the question. Either one can answer. If you come to a conference like this, there is a huge debate about Exascale and the future of computing and the very high-end systems. And of course, we focus a lot about the sort of top 5 systems and the top 500 and so on. So is that debate helpful or hurtful when you try to reach out to smaller scale systems, to small companies? I mean, I could envision that reaction as well. This is what the big guys in government labs are doing. It doesn't really impact us at all. So if any thoughts on Exascale being hurtful or helpful for?
I would say it's largely irrelevant, because even the big companies in Korea, like Samsung, when they are doing the computation of the order of like 10 teraflop scale systems. So especially for the industrial application, especially some SME, that this discussion is largely irrelevant.
Okay. Karen, any thoughts?
As far as I know, Exascale is not an issue. It's far, far away from their daily work, but it's like Formula One cars and your normal car. If something is developed that will help your normal car, they will take it.
Eventually. So related to that, there was actually an interesting topic that came up yesterday again in the top 500 discussion, and I think Eric Strohmeyer provided a very interesting analysis that showed that, in a sense, the gap between, let's say, the bottom 400 and the top 100 is widening, or maybe even the gap between the top 10 or 20 and the bottom 480. And he explained this, that the top 10 or 15 systems are all now making use of accelerator technologies of GPUs and have seen significant performance increase, and the rest of the list hasn't really, to a significant extent, adapted GPUs or accelerator technology. And so there was a conjecture that there is a gap, an acceptance gap or an adaptation gap in industrial use of the latest technology in the form of GPUs and accelerators. And I'd be curious to hear opinions from you if you have observed this, or if there are already great examples out there to your knowledge in terms of industrial use of accelerator-based systems.
So I don't think it's an acceptance gap, it's more a time gap. Because hardware is one side, software is the other side. You always have to adapt your software to take advantage of this new hardware. And if it doesn't run faster, nobody would invest in a newer hardware. So we are taking part in a project, in a Tier 2 Europe project called H4H, that's dealing with analyzing and optimizing software on heterogeneous architectures, especially with this GPU stuff. And we are on the trail, but of course it takes time until it reaches the small and medium-sized companies.
So Microsoft is committed to port your software on accelerator-based systems at this point?
We are on the trail. We're
You're on the
just
trail.
checking what can we reach, how
Okay.
fast can we get, and then we tell our customers, okay, we have a solution. Who wants to buy it? And we already have customers who ask for it.
Okay.
We showed
That's
it at
good.
a user meeting, at our international user meeting, and the first questions came up, when can we buy it?
Well, that's good.
And I guess, I mean, we know that accelerators are good for certain type of problems, and this is not different from also in the industrial applications. So I believe inherently there is a potential for these new technologies to take advantage of. But I guess the main factor is probably the software, especially small to medium industries. I mean, they don't have a capacity to write their own software. So it probably is a job of these ISVs that has to port the software to take advantage of the functions there, like Magma.
Yeah, exactly. Certainly in the U.S., the differentiation that you mentioned can be seen with the big industrial users in various sectors. Particularly, it comes to mind that the financial sector certainly uses the accelerator platforms for the work that they do. But the trickle down to SMEs is really going to depend upon the software that they currently run now, being able to run on those new platforms. And I'm sure that the ISV community will start migrating there when there's more demand for that, or that those are the only systems that are available. They will certainly migrate to that. But I also wanted to touch on your previous question about the exascale piece,
Right.
because I wanted to point out that in the U.S., the big users, or the power users for supercomputing, they do talk about the exascale horizon, and that it's going to have an impact on the codes, their proprietary codes, because the undergirding technologies are going to change, the chipsets, et cetera. So they're very aware of that, concerned about the timeline for them to make the change or adapt to the new systems that come out. But they're really very excited about the fact that the new technologies will allow them to have access to petascale computing, on the desktop, so to speak, or a cluster. That's a petascale cluster. So that's what they really are looking for, the new technology to drive petascale to a price point and size that they are able to use.
Thank you. We touched about this already a little bit when we talked about software, so let me ask that question in a more general context, and just, it's kind of always one of my favorite questions. If you had a magic wand, if one wish would be granted, what would you ask for in terms of what is the biggest barrier that's currently holding back industrial use of HPC? And if you could sort of change one thing overnight, what is it that you would change? And then, of course, everything else would be easy from then on. So I'm not sure if there's one big thing, but let's just say, what's the biggest barrier in your mind that you would like to see overcome so that HPC would be more used by industry?
So I mean, we have been supporting small to medium industry for like 6 or 7 years, and basically two barriers is infrastructure and human resources. That's the two axes. And regarding infrastructure, there's a way that you can deliver fast, but human resources is much harder problem. So I guess if I can have one wish, then we have all the experts suddenly appear in front of me. That's all the problem. So,
Okay.
I concur with that.
Okay, experts?
Absolutely. It's the expertise that's a barrier. If all the software and hardware were free for SMEs, they wouldn't have the sufficient expertise internally or know where to get that expertise to use the systems. And there are a few universities out there that are looking at how can we help with the pipeline of experts in terms of generating them. And the University of Chicago is one that's looking at new degree programs that can enable the end user of the technologies to upskill so that they could use high-performance computing for their advantage. So I think the ground is moving, that the universities are realizing that there is a demand out there that's not being satisfied, and they have an opportunity to satisfy that demand outside of computer science.
Karen, any?
I would a little bit change the point of view, because for small and medium-sized companies, it's always a question who supports and maintains a system. And if I could tear down one barrier, I would say I would like to have hardware you could put under your desk. You don't need an extra room with extra air conditioning. You don't need somebody who knows about all of this hardware stuff and about probably a different operating system. Most people have Windows, are used to it. And if you tell them, okay, you have to buy a cluster, and they say, okay, and they say it's running under Linux, and they say, oh, I don't know anything about it. Who should maintain and care? And bigger companies can engage people who know about it. But smaller companies, they have to deal themselves with the stuff. And it just has to be easy to maintain and to use.
Yes, but in short, it's another expertise in human resource issue that you see as a barrier. It's just a different type of person than what Jisoo and Cynthia were looking for. I mean, it is a human resource issue. Or you think it's automation is the answer to that issue? Do you think that's possible?
In smaller companies, you often have people without scientific background. And it's not easy. It's quite complicated to have a software and a hardware that can be used by them without too much hassle-free, I would say.
Well, we've in working with small and medium-sized manufacturers to use software packages, FEA and CFD packages. The universities have created applications on top of the software so that the SME doesn't have to deal with the entire software package, but can be very focused. And that's been helpful to the companies that we've worked with. We talk about the issue of applications on top of the undergirding software and how pervasive will that become. What are the issues of liability if someone doesn't quite understand that their input doesn't quite fit the application that they're trying to address? So you still need a lot of interface. Even if you have an app on top of the software, you need an expert to tell that SME that, yes, this really can help you solve that problem, and not let them sort of wander into it and then get some false information. So it's still a challenge, and you still need the experts, even though you're making the entry easier for them.
So actually one answer somebody might give you, Karen, is that, well, let's just put everything in the cloud. Is that truly a solution, or
no,
what?
Not
No?
at all.
Not at all.
So
Why not?
security issues are really important, and some of our customers are doing, or a lot of customers are doing prototyping, and all the knowledge about the processes and materials and what distinguishes them between the competitors is in the simulation. So they don't want to give it away.
So basically, the question of security of data and models is
very
a
important,
big issue for cloud users.
Yeah. So a few years ago, everybody jumped into cloud computing. Also, MachMine took part at a project that was addressing cloud computing. But what we need much more is tools that help us to develop the software. And HPC projects were quite rare, so we took part at this PARMA project. I think it was starting 2006, and it was the only HPC project then. Every other project was just cloud computing.
Yes.
So, and as it came out, not so much people use it.
Jiso, any thoughts about cloud computing? And
I guess for the Korean SME companies, I mean, it's really good fit. Because I mean, as I mentioned, that it resolved the issue of the infrastructure cost. It's much, I mean, it's economical model to deliver the service, and also for the, I mean, like a SaaS model of the cloud computing, it just makes it much easier to company to access and lower the barrier for the interface. So I would imagine it's that cloud computing is a really good fit to SME in Korean companies.
Very good. Any thoughts on cloud computing, Cynthia?
Nothing that
Okay.
differs from my colleagues here.
So I'd like to sort of ask my panelists here one question, and then maybe we'll open up to a few questions from the audience. So the last question that I'd like to ask you, and just want to lead up to this, is a hopefully easy one, and this is that as you come to a conference like ISC and you talk to colleagues and you go around the exhibition floor and you see what's done elsewhere, have you picked up some best practices elsewhere in terms of the missing middle and bringing SMEs to high-performance computing that you'd like to bring back into your home institution or in your home country? Or you still haven't had enough time to wander around and talk to people? I don't know. Anything you noticed which is notable that could be useful?
I guess it probably is not limited to missing middle, but I mean, when we all are amazed with the success of our Chinese friend. And so actually I did a little study on how the history of their HPC. And what was amazing is that they have pretty consistent policy of at least 15 or maybe 20 or 30 years. And that is really the thing that just kept everything going. So, I mean, if there is one thing that I want, then from my government, I mean, they are doing really well now, but if I ask more, then just really consistent policy over the long period of time, that's really important in making real progress there.
Okay. Cynthia?
I think that what's interesting at this conference that I've noticed, that the BRIC countries are certainly moving forward with acquiring HPC systems and deploying them not only for scientific but for industrial purposes. And so you have Brazil, you have India, you've got South Africa, and certainly Russia, all looking at this technology as an accelerator of economic security for each country. And so I think I see that more here in conversation and posters and presentation than I have in other places.
Okay, Karen?
So I arrived yesterday afternoon. I didn't have so much time, but what I recognized when I went around, that more people think about how to bring cluster to small and medium-sized companies. So make it look not so huge, this huge racks, so making it look nice like a desktop. And I think with this development goes on, it will surely help us to say, now we have a solution for you. Something like out of the box, you can buy this or this stuff and it will run very well with our software, and you have something you can work with.
Okay. Thank you. So I don't know if you have microphones. If you don't have microphones, then I'd like to ask you to speak up and state your name and ask your question, and I'll just repeat it so that everybody in the back of the room can also hear it. So are there any questions? Yes. Oh, there's a microphone. Okay, very good. All the way in the back. Sorry, Scott.
don't make it too easy.
They're making it difficult to ask questions.
Ask questions, exactly.
All right, so I guess I'm tired by the time I got here, but so my name's Scott Klasky. I'm from Oak Ridge Lab, and one of the things, so I have a comment/question. So one of the things that I've seen is a lot of people who are looking at, say, analysis, analytics, visualization, typically these things don't scale real well. So we're looking for different clusters, different cloud-like models. And one of my questions is really in terms of things for this middle range of computing in industry, what exactly are people looking at? Are they looking at running what we call reduced model codes, fairly, simple models that, engineering codes that just a few cores? Or are you looking at massively parallelism, embarrassingly parallelism, where you can have map-reduced work? I mean, what is it that you're looking for? What are people doing there that perhaps, is different from HPC?
Okay, so in short, I think Scott's question was, what is it that industrial and SME users and SMEs are actually trying to compute? What are they using? Packaged application software? Are they using massively parallel data analysis? Are they doing parameter studies? How would you characterize the space of HPC users?
For our particular case, we are mostly supporting manufacturing SMEs. So, the software they're using is this analysis software, like from ANSYS, for Lastron, this kind of software they're using it. And they're mainly for the kind of scanning the parameter space. So they are not doing pretty massive calculation. They are doing lots of small calculations to check the parameters they are looking for. That's the situation in Korea.
As always, it depends. So we have foundries who just want to simulate the process chain, optimize it, find out what's going on. We also have casting designers and casting users, and they are using our software just to simulate if what they designed can be casted, so in advance. And it's used for prototyping and research, and it is also used just to set up an economically successful process, because this is for foundries, this is very important to earn money, of course, and to save energy consumption and materials.
Okay. Any other questions from the audience? Yes, all the way in the back. Gary.
So both in the US and in Europe, I'm not quite sure about Asia, there are programs in place to make significant amounts of time on very high-end systems available for industrial use. And so my question is, to what extent are these programs useful in bringing people from the missing middle sort of upwards in the hardware and applications spectrum?
Thank you. So that was Gary Johnson from Scientific Supercomputing Solutions, correct?
Computational Science Solutions.
Oh, computational science.
Pardon me for not introducing myself.
Okay. Cynthia,
The,
you have a lot of
yes,
interaction with DOE
with
and the
DOE
INSIGHT program.
and the INSIGHT
So you have,
program that is competitive for the industrial base. The companies, I'll talk about two sets. The very high-end users, major OEMs, they go after the INSIGHT opportunity because it gives them access to platforms, computing platforms they don't have in-house, and they are able, one, to do problems that they can't do internally on the resources that they have, because they can't have those resources dedicated for long periods of time. So they see it as an opportunity to test out new systems and then perhaps be able to make a case for acquiring a new system, having run on DOE's platform. So they see it as a great test bed for their research activities as well as understanding new platforms from their perspective. Insight also has some very small companies that have been successful in getting allocations and winning through a proposal process. And Gene Network Sciences is one that I know about that's a very small company that does modeling simulation of biological systems. And they got an Insight Award. So for them, it opened up their innovation space because of having access to the platform. So it's not most of the SMEs. Most of them would probably not take the time and effort to apply for the Insight to run on DOE systems. But for those who see it as an opportunity that their problems need to run on those types of platforms, it's a great opportunity. And then they take it to the next level. Can I buy into or get a CRADA with DOE so I can run on their systems now that they've seen the benefit of it? So it very much helps their innovation space and then allows them to understand how to get to the next level of compute, either through a contract relationship with DOE or through an acquisition.
Any thoughts on the
I guess
use
for
of
our case, we have some statistics. I mean, we have about 150 companies. So what we have done over the time is that we just did a survey of what is the actual benefit to the company. So, I mean, on average, they have the time to solution is half the other time when the HPC was applied. And also the development cost also it was become half of what it used to be. So I mean, it was a very, very clear value that proposed to these companies there.
Karen, do you have any views on how the praise systems are used and useful for industrial users and how they can get allocations?
In our case, we have our own benchmark projects. We are running on different hardware. And often our customers have their benchmark projects and we run them for them on the hardware they want to buy. And they can then look, whoa, what can we reach? We have an engineering department that offers engineering services and consulting. And this department is also doing calculation and simulation for our customers. And they can then see, okay, we don't have the hardware in-house, but you have a cluster, can you run it for us? And then they get the answer much faster. So they know what they can get out of this hardware, but sometimes they don't want to buy it because they don't have always the projects for this huge hardware, but only for the hardware they have in-house. So it's just a little bit what you would achieve with cloud computing.
Okay, I think we'll take one last question, if there is one. Anwar, please.
Anwar Oseiran from Sarah in Amsterdam. I'm one of the big fans of the Council on Competitiveness in the US. And as you probably know, there is, in the meantime, also a Council on Competitiveness in Europe. I don't know if there is a contact between both councils. I was wondering how are you funded? How is your success measured? Is it by decreasing the deficit on high-tech export in Europe and the US? It applies for both councils. And the other question is, how much did Intel pay to use your slogan, outcompute to outcompete?
So I won't comment on the last question, but certainly the council has relationships with other competitiveness councils across the globe, actually. Europe, Ireland, Saudi Arabia has a competitiveness council, Brazil does, Korea does, Japan. So we have bilateral relationships with many, if not all, of the competitiveness councils across the globe. We also established a new organization called the Global Federation of Competitiveness Councils, where all of them meet on an annual basis to talk about common productivity drivers, things around education, around innovation, et cetera. So that's an opportunity and something we created to bring all of them together to help one another to improve their economies, because we all benefit by a rising tide, basically. So we've done that. We've talked to some of them have talked to us about high-performance computing's role in economic security. Brazil has approached us with that as a topic from their Competitiveness Council. So it is an opportunity for common problems and common solutions to be brought forward and to assist one another in doing so. So we encourage that. There is competition, but it's who's got the best idea and who can get it out faster. We certainly want the U.S. to be in the lead there, but we know that good ideas are everywhere. And so new products and new services will come from all countries, and we want everyone to be a player and for all of us to benefit. So thank you for asking about the council. And we see the opportunity for partnerships, public-private partnerships in country, between countries, to enable greater productivity for all. Thank you.
Well, with that conclusion, I'm not able to add anything. Great ideas are everywhere, and I'd like to use them. That's
exactly.
Great slogan. So with that, I think we should close the chat, and I would like all of you to join me in giving a round of applause to my fellow panelists here and thank them.
Thank you.
Thank you very much, and enjoy the rest of the conference.